Ladies and gentlemen, welcome to another video. It's PVS the Tutor, the best online tutor. And in this video, I want us to talk a little bit about the equations of motion and what role do they play in our day-to-day activities as we conduct our motion. Now, the word motion, it has to do with movement. Now, we are interested in linear motion at the moment, all right? So these equations, they are known as equations of motion. Equations of what? Motion. Depending on which variable is available, you are able to calculate the other variable. For example, in the first equation here, we don't have distance, but we have final velocity, initial velocity, acceleration, and time taken. So we can find any of those depending on which variable is what available. These are also called the Suvatty equations. They are also known as what? Suvatty equations. Now, these equations usually they are used when acceleration is constant. In most cases, they are used when acceleration is what is constant. Is it making sense? So now let's explain what each term means. This V means final velocity. All right. Then this one means initial velocity. Then we have S, which means displacement. Sometimes it can mean distance. Then A is the acceleration. And the T is for time. So we have those, all right? We have those. I think each and every variable has been talked about there. So this is what these variables do mean. Now, based on what is available, all right, you should be able to express the final answer in the correct base units, all right? For example, let's say you are finding velocity in this case. After evaluating everything, you should be able to express that answer in the correct units for velocity, all right? And just a recap, we know that time, all right, which is t, the SI unit is second, small letter s. Do not write capital letter S. Once you write capital letter S, we are not talking about what? Displacement or distance. All right. Then we have displacement itself, which is this. This is just meters, which is length. Then we have velocity. Velocity is meters per second. Acceleration is meter per second watt squared. Sometimes you can find this one written as meters then to the power negative 1. It's the same because this is just according to indices division. Or sometimes you can find this. They are the same. There's nothing different there. Let's look at an example. So this example says a car is traveling with an initial speed of 10 meters per second and acceleration of 5 meters per second squared. At what speed is the car traveling when it stops accelerating? All right, so we are going to correct all the data that we have so that we can choose which equation of motion we are going to use. So we are going to write data. So write data. All right, we have initial speed. So we say U, it's 10 meters per second. We have the acceleration. Okay. Yes. So it and acceleration of this one, let me just include the time. Let's say for 3 seconds. Let's go it for 3 seconds. So we have time 3 seconds. We have acceleration 5 meters per second. What is missing? At what speed is the car traveling when it stops? So when it stops, it means it has come to rest. It has gone to final. So we're looking for the final velocity, which we don't know. In physics, once you do this, trust me, it will be easier for you even to remember which equation of motion. But once you are just reading the data the way it is, even to choose which equation of motion to use, it will be quite difficult. When you do this, you save yourself some time. So now we know that the equation of motion that we are going to use here is the first one. All right, it's the first one. So we are going to use this one. V it's u plus at, because we're looking for this guy here. So V is, what's your initial velocity? It was 10 meters per second, plus acceleration was what? 5 meters per second what squared. What was time? Time was 3 seconds. Now you can clear that this second and one of the seconds here, they cancel. All right, they cancel. So you remain with the V is 10 meters per second plus 5 meters per what second multiplied by what 3. That's how come velocity has got also meters per second, because this is what happens, they cancel like that time. So V is 10 meters per second plus we get 15 meters per what second. Then you just add them, you get 25 meters per second. These are like terms, you can just add them and keep the variable. So this is how we can use this equation of motion to answer questions. Let's look at the last example. Example 2. Suppose that a ball is dropped out of a plane and it accelerates towards the ground at 9.8 meters per second squared. After 4.0 seconds, it hits the ground at 40 meters per second. At what speed was it traveling when it left the plane? Now, as usual, data, very important. We have acceleration, 9.8 meters per second squared. What else do we have? We have got time here. So time is 4.05 seconds. What else do we have? Speed, which is now, look, after this it hit the ground, that means it has now gone to rest. So that is a final. So this is a final velocity. So we have this 40 meters per. At what speed was it traveling when it left? So when it left, that was initial. We don't have. We know the equation of motion to use. All right. So you can join our online classes if you want to see other examples of other equations of motion. For now, we'll just look at the first one. But if you want to benefit, you can. I'm sure you've just seen how we are dropping out the concept and doing everything. Back to the question. So we have velocity, which is the final, its initial and acceleration times time. You add them together. So here we have 40. Our initial we don't know. Our acceleration has been given. Now, this is why I want you to pay particular attention. Yes, I know that the equation of motion is like this, but this ball is dropped, so it's like this. That is what it is happening there. So it's moving. It's falling under the influence of gravity. In short, you get the concept, right? All right, because of that thing. But yeah, we can also just solve it the way it is. But you just have to recognize in the end that this stone or this bossary is falling under the influence of what? Gravity. So our acceleration is that one there, 9.8, then time is 4.05. So get your calculator, punch 9.8 multiplied by 4.05 and tipeza chi 40 uku, and that one there, and tipeza chi 39.69 uku. So tizacha correct in like terms tefibane. So we have u just 40 minus the 39 and 69. Well, subtract them. U is 0.31. What are the units for speed? Probably lost just per second, right? There's no problem. You cannot put units. Then at the end of the final answer, you add units. But in your working, it's okay even if you don't put, but don't forget to put them at the final answer. I leave you with this, and I hope you enjoyed it. Remember, subscribe, follow me on TikTok, and my Facebook page is Previous the Tutor. TikTok Previous the Tutor. Online classes, kanamba kaso. Feel free. Our classes are very much affordable. Very, very affordable.